Okay. Average rate of change of a function of an interval over a blah, blah, blah is given by, I don't know if people want to the amount of change divided by the length of the interval. Does this kind of look familiar? I'm getting a head nod. No. Close. Slow. So I have some point x1, y1, and some point x2, y2, and it does some funky things. And I ask you for the average rate of change between those 2 points. You guys would call that slope, and I would call it delta y over delta x. And I also would call the blue line a secant line. Any line that joins 2 points on a curve is called a secant line. Secant line. Okay. So find the average rate of change over the interval, 1 to 3. So what I would like you to do is to find the 2 y values. So when x is 1, what's y? When x is 3, what's y? Zero. When x is 3, (27 minus 3 is 24). So delta y over delta x is equal to 24 minus 0 over 3 minus 1. Mr. App, the slope is 12. How's that? Math 10, right? Slope between 2 points? Okay. Blah, 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 blah. Draw a graph of the function. What is this average rate over the change? Gives you the slope of the secant line. Do we need to say that again? No? Gives you the slope of the secant line. Okay. Is that page? Do you want me to draw a picture of that, or do you kind of get the idea? I said it gives you the slope of the secant line. So what we're doing is what is it, 0, 1, and 3, 24. And we know it's, so it probably looks like this. I don't know, I'm guesstimating. So it's just telling you the slope of that line. Physics people should be used to seeing that blue triangle in there, hey? And it rises 24 units and runs 3 units. The slope is, or sorry, runs 2 units. Stupid. Oops, not 0, 1, 1, 0. Anyways. And it says the slope is 12. Yeah? It just gives you the slope between the 2 points of the secant line. Secant line joins 2 points, blah, 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 blah. Okay, flipping page. So, in a controlled experiment of a fruit fly population, it was found that in 23 days there were 150 flies, and in 45 days there were 340 flies. What is the average rate of change of the fruit fly population? So what we're saying here is, I'm just going to draw a sketch. What we're saying here is at the 23rd day, we have 150 flies, and at the 45th day we have 340 flies. So what is the slope? What is the average rate of change? Delta F for flies over delta T. Well, we went from 340 or 150 up to 340. What do you got? .6 flies per day. Fruit flies. Ugh. Okay. What would happen if you wanted to know how fast the population was growing on day 23 itself? So what I'm going to need to do is I'm going to take this point here and I'm going to slide it back to here and draw a new secant line. And then I'm going to change and I'm going to go back to here and I'm going to draw a new secant line. And then I slide it and move the point back and draw a new secant line. And I'm going to move it back and draw a new secant line. And then I'm going to move it back and I'm going to draw a new secant line. I'm going to keep on doing this until the distances between those two dots are 0. Now, can I do this graphically? No, because my graph isn't accurate enough. Can I do this algebraically? Yes, it's a limit. So what we would like to do, so what would happen? Well, if we did this graphically, we would divide by 0, and that would be bad. But what we would like to do is we would like to delta f over delta t would be the limit. Give me some letter. I don't want to use x, because x usually you think about it as coordinates. I can't use f, I just put an f. N, okay, as n approaches 0, of the fruit fly population at 23 minus the fruit fly population of 23 days plus some n units right. That's me taking that point and just sliding it closer and closer. So if I wanted it 1 day to the right, n would be 1. It would be 24 days. If I wanted it 2 days to the right, n would be 2, and that would be 25 days. So all I'm doing is changing the number of days down. So at 45, n is 12. And I'm just changing from 12 to 11 to 10 to 9 to 8 to 7 to 6 to 5 to 4 to 3 until it's right on top all over y2. Why do I have those backwards? Oh well, who cares? They should be the other way around. But what happens? Well, usually it's y2 minus y1, not y1 minus y2. But for me, it doesn't matter. I see it the same way. What's going to happen? What happens to the 23 in the denominator? Hello? What? Are you just left with negative n? Because the 23s are going to cancel. Now, can we do any algebra from here? Can we substitute 0 in per n? No. We're going to actually need to create a formula that will represent the number of fruit flies at any time, and then we're going to do some algebra. But what I want you to do is get that intuitive idea of what we're doing. We're taking the point at day 23. Here we are at the 23rd day. We're going n days to the right, and we're drawing a secant line. And then we're just shrinking n down each time until the line changes from secant until it is tangent. Okay. So the moral of the story, here's how you write it. Delta y over delta x, also known as slope, is the limit as x approaches a of f of x minus f of a all over x minus a. This is one way of writing it. So what we're saying here is we're at the point a comma f of a, and we're going to go some point to the right, x f of x, and we're going to slide x back until it's right on top of a. And as we do that, our secant line changes into a tangent line. The other way of doing it is to define slope this way. Oh. I'm going to show you the other definition. This one's not my favorite definition, but it is a definition. The other way to define it is this way. We go have some point on our curve, x, f of x. We go h units to the right. It has the coordinates x plus h, f of x plus h. And all we do is change, instead of h being 6, change it to 6 to 5 to 4 to 3 to 2 to 1 to 0. And what happens? We change from secant lines into tangent lines. I'm a proponent of the second formula. I don't use the first one very much. I don't use it at all, actually. Okay. Pardon me? Well, I'll show you. This is our formula that we need. We're going to put a big box around this. Okay. So find the slope of the parabola at the point. Write the equation of the tangent to the parabola at this point. So the slope, m equals limit h goes to 0 of f of x plus h minus f of x all over h. So limit h goes to 0. So all I'm going to do is take out f of x plus h and put it in what it... I better do this over here. F of x is x squared. F of x plus h is folks, what's f of x plus h? X plus h all squared. Okay. Give me something you can do with this. Good. Foil it out. You wouldn't believe how many kids couldn't do that on the provincial exam. You couldn't multiply x plus h all squared. I think it was x plus 3 all squared. I think that we saw so many x squareds minus 9, it wasn't even funny. X squared plus 2xh plus h squared. Now, do you want me to go somewhere and foil that for you, or are you okay with what I just did? Give me a thumbs down if you want me to write down what I just did. No thumbs down. Okay. Minus x squared all over h. What do you notice? X squareds cancel. We are in our happy place. Goodbye, x squareds. So you get 2xh plus h squared all over h. What can you do now? Split it apart or factor out an h. So you got two strategies here. I'm a factorer, so, and you're going to be doing that so much in the next couple of chapters that it's just, you could split it out. Do you want me to split it apart instead, just to show you that it works that way as well? Okay. You don't have to write it down. So those kids who like to split things apart would do this. And lo and behold, you get the same thing. What happens to the h? You can put 0 in for h now. So it becomes 0. So you're left with 2x. So the slope at any point on the curve is always just twice its x value. Cool? Greg? No? I think that's very cool. Parabolas have that really funky property that the slope anywhere along a parabola is always just, and that's a really interesting point because that's the only point on the parabola where its y value is twice its x value because it's x squared. But anyways, the slope anywhere along the parabola is just twice its x value. So if I know its x value, I know its slope. No. So we know the slope there, Mr. App. We know the slope is just 2 times 2. So the slope is 4. So the equation of the tangent line is, do you guys want to write it in y equals mx plus b form, or do you want to do it or in a really faster way? Who wants to write it the faster way? Only 2 of you? The rest of you suck. Y minus y1 equals mx minus x1. This is my favorite line formula in the whole world. You might have seen it in grade 10, maybe. I don't write things in y equals mx plus b. It's too much work. So it's just y minus 4 equals m 4 x minus 2. So there's your tangent line. When you're finished. How do you make it y equals mx plus b? Get rid of all your brackets, kick it all, everything over to the right-hand side, and leave it as y equals. But why? Why? Unless you have to do it, don't. How's that? We good? Okay, we're going to go for 10 more minutes. So, we're going to define slope as blah, 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 blah. Boy, that looks familiar. So find the slope at the point y f of x at the slope. I just want to, there. As long as x doesn't equal 0. Okay. So m equals limit h goes to 0 of f of x plus h minus f of x all over h. No, h goes to 0. Not x, h. So what we're saying here is we've got the curve, y equals 1 over x, and I'm going to some point on the curve, x, and then I'm going to go h units to the right of that, and I'm going to join those 2 points of the line, and I'm going to slide h. So I'm going to start with a really big h, and then I'm going to slowly change h so that the distance between those, oh my god, pink and green, become the same point. Okay, that's what I'm doing. I'm not doing x equals 0, I'm doing h equals 0. Okay. Or I'd like h to be 0. Okay, so we fire in it into the formula. What's f of x plus h going to be? F of x is 1 over x. F of x plus h is 1 over x plus h. Good call. So 1 over x plus h minus 1 over x all over h. Usually this is where the grumbling starts. Mr. App, I hate fraction. Sorry, folks, this is AP calculus. Suck it up. What's the grand common denominator? Well, you know what I'm even like, what's the common denominator? X times x plus h is the grand common denominator. You can't just do this.
Thank you.
Okay? No? You don't like, you like that? It's a Monday morning. You might go like, wow, that's cool. I wish I could do that. Not lately. So, I'm going to times top and bottom of this fraction by x times top and bottom of this fraction by. Do you guys want to do it a different way, or does this make sense to you? So, unfortunately, it's going to get a little bit unruly, but that's all right. So x times 1 is x. X times x plus h is x times x plus h. Minus x times 1 is x. 1 times h is all over h. All over h. Okay. Here's where... Oh, I'm going to run out of room. No, I'm not. Here's where you need to be careful. Because kids ignore that minus sign. It's actually like this. X minus x is 0. Minus h, minus plus h, negative h. Most kids ignore that minus when they're dealing with the h, and that's a problem that I have. So you got to remember that when you subtract, there are actually, in fact, a large set of brackets around that whole second fraction. That's not a bad strategy. Not a bad strategy would to do exactly what Cam suggests, is to put a plus here and then distribute in the negative. Good call. That's not a bad strategy. All I'm saying is be careful when you're subtracting. So x plus negative x, 0, plus negative h, negative h. All over h. Ours is not to question why. Ours is but to flip and multiply. Instead of all dividing by h, just multiply by 1 over h. And then your h's cancel. And you think to yourself, why is that a good thing? Stick 0 in for h now. X plus 0. X plus 0. X. So your denominator becomes negative 1 over x times x plus 0. Negative x squared. Or 1 over negative x squared, sorry. How are we doing? I'm going to test your fraction skills in this section. Okay? This is where your, as a friend of mine says, low ass. lack of algebraic skills. Anyways. I'm going to test you a little bit on that. Where are we at? Where are we at? Where are we at? Where does the slope equal negative 1 over 4? Okay, we'll do that, and then we'll stop for a couple of minutes. So, m is negative 1 over 4, and that equals negative 1 over x squared. One could do this by inspection. Look at it. Or one could do it through algebraic manipulation. Or negative 2. So we could, in fact, multiply both sides by the common denominator, which is 4x squared, and you get negative 4 equals negative x squared. Divide both sides by negative 1. 4 equals x squared at the point x equals plus or minus 2. There are 2 points on the curve that have a slope of negative 1/4. They are right here. It has a slope of negative 1/4. This is kind of a funky function because the reciprocal function is one of the only functions that has negative slope everywhere. It's always falling. It's kind of funky. It's always falling. I guess there's an infinite number of functions that fall, but I just think it's kind of cool because it's always falling. They both have slopes of negative 1 over 4. Cool? Okay.